On this next page, we are going to practice graphing exponentials and logarithms. So for the following exponentials, we know that their domain is always going to be negative infinity to infinity, but their range will depend on their asymptote. In number 13, we know that this function has an asymptote at y equals 2. To find the y-intercept, we want to plug in 0. So we have 3 to the 0 plus 2, which would be 1 plus 2, which equals 3. So we have a y-intercept at 0, 3. For an additional point, we can plug in any point that's convenient. I think it would be easy to plug in a -1 because that would make our point 3 to the first power plus 2, which is 5. And if we graph it, we have our horizontal asymptote up at 2. We have our y-intercept at 0, 3, our point at -1, 5, which means that we have a decay graph, which makes sense since the exponent is negative, and our range would be from 2 to infinity. Number 14 may be easier to rewrite as negative e to the x plus 1 plus 3. This way we know that our horizontal asymptote is going to be at y equals 3. Our domain is negative infinity to infinity since this is a exponential. To find our y-intercept, we just need to plug in 0. So we have negative e to the first plus 3. We know that e equals about 2.7. So negative 2.7 plus 3 would be at about 0.3. And for an additional point, we want to plug in a point that's convenient. So a good point to plug in would be -1, because that way we get negative e to the 0 power plus 3, which would be -1 plus 3, which equals 2. So we have a point at -1, 2. And if we graph this, we have our asymptote up at 3. And our point is at -1, 2. And our intercept is at 0.3. So our graph looks like this. So our range is negative infinity up to 3 since it's below the asymptote. On this page, we're graphing logarithms. So when we graph a logarithm, we always know that their ranges are going to be negative infinity to infinity. However, their domain is restricted by the vertical asymptote. So since we cannot take the logarithm of 0, our vertical asymptote is going to be x equals -4, because if I plugged in -4, I would get a 0. So our domain is going to be from -4 to infinity. To find the x-intercept, I want to set my logarithm equal to 0. So I have 0 equals log base 2 of x plus 4 minus 3. So if I add the 3 to the other side, I have 3 equals log base 2 of x plus 4. And if I exponentiate it, I have 2 to the third equals x plus 4. 2 to the third is 8. So I know that I will have my x-intercept at x equals 4. So when I graph it, my vertical asymptote is at -4. My x-intercept is at 4. And to get my additional point, I want to move my key point from 1, 0, which is usually where logarithms intersect the x-axis, and I'm going to move him 4 to the left and down 3. So my additional point is at -3, -3. And you always can find that using your shifts. So my logarithm graph is going to look like that. Natural logarithms are graphed the same way as logarithms. And again, to find the asymptote, we want to figure out what would make the logarithm go to 0, which in this case, it would just be x equals 0. So we know that our domain is going to be from 0 to infinity. And our range is always negative infinity to infinity. To find the x-intercept, we want to set it equal to 0. So we have 0 equals the negative natural log of x plus 1. So if I subtract 1 and divide by the negative, I have 1 equals the natural log of x. So e to the first would equal x. So my x-intercept is at about 2.7. So I have my vertical asymptote at 0 and my x-intercept at 2.7. And to find my additional point, I want to use my shifts. So I'm going to start at 1 and just move up 1. And because this is a negative natural log, I know that it is going to be decreasing. So my additional point ended up at 1, 1. The following word problems you are allowed to use a calculator for, and they were the word problems that we went over in class in groups. So for number 1, if $9,200 is invested at 9.5% interest compounded continuously, find the balance in the account after 10 years. So this is a compound interest equation. So we're going to use the formula for interest that is being compounded continuously, which is A equals PE to the RT. P stands for our principal, so we are going to plug in 9,200. Our rate is 9.5%. So we're going to plug that in as a decimal as 0.095. And our time is 10 years, so we're going to multiply that by 10. So now if you put that in your calculator, you get $23,788.53, which is choice E. For number 2, we want to determine the annual rate of interest compounding continuously for the sum of money in an account to become triple the original amount in 10 years. So in this case, we don't know our principal, but we do know that the amount is going to triple in 10 years. So if we don't know our principal, we can leave it as P. We're trying to solve for the rate, but we know that our time is 10. And we know that our principal is going to triple, so we could set the amount as 3P. Then if we divide by P, we're just left with 3 equals e to the 10r. And then if we take the natural log of that, we have the natural log of 3 equals 10r. And then to define the rate, we just need to divide by 10. So if we put that in our calculator, we have the natural log of 3 divided by 10, which is 0.11, which is 11% interest. If you want to get fancy, you can leave it as 10.0198, so 10.98%. I would accept either answer. In number 3, we are given the equation of a flu virus that is being spread, and we want to know in how many days will 820 people be infected with the virus. So in this case, we're solving for t because we want to know the number of days. So we're going to set y to 820. So we have 820 equals 1,000 divided by 1 plus 990, e to the negative 0.7t. And the trick that we learned in class to solve this is to switch the 820 with the denominator. So we have 1 plus 990 e to the negative 0.7t equals 1,000 divided by 820. And to solve for e, we want to subtract 1 from that. So we have 990 equals e to the negative 0.7t which equals 1,000 divided by 820 is 1.2195. Subtract 1 from that. So we have 0.2195. And if we divide that by 990, we have e to the negative 0.7t equals well, we have a small number, so we will probably just put it all in our calculator at one time. All right, so now we want to take the natural log of that. So we have negative 0.7t equals the natural log. And then the very last step would be to divide by negative 0.7. So our final answer is 12.02. So it would be 12 days. Oops. There we go. For number 4, we want to find the constant k so that the exponential function y equals 3e to the kt passes through the points 0, 3, and 3, 5. So we can plug in 0 for t and 3 for y since we're solving for k. So we have 3 equals 3e to the k times 0, which would give us 3 equals 3e to the 0, which basically just tells us that 3 equals 3. So that one didn't really help us solve for k at all. So let's try to plug in the next point and see if it helps us solve for k. So we end up with 5 equals 3e to the 3k. And if we divide by 3, we have 5/3 equals e to the 3k. And if we take the natural log of both sides, we have the natural log of 5/3 equals 3k. And then we can divide by 3 to get k. So k equals 0.17.